What is up, Chemistry Chaos? This is episode 9, gram stoichiometry. Whew, it's a big doozy of a subject, but we're going to get through it. Alright, we're going to go ahead to our first example. Our first example, stoichiometry allows you to predict how much of a substance is needed or formed. In this equation right here, we can read it in stoichiometric terms as 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of hydrogen or dihydrogen monoxide, also known as water. The funny thing is you guys have learned to use mole stoichiometry to determine the amount of moles mated. Well, we're not talking moles anymore. We're talking grams. And we can't plug grams into the molar ratio. So what we need to do first is convert the amount of grams given into moles so we can use it. Alright, so let's see how this works. If you want to make a sandwich, you're going to need 2 slices of bread. Well, you can see there is a 1 sandwich to 2 pieces of bread ratio. 1 to 2. If you want to make 2 sandwiches, we got to keep that ratio true. So we have 2 sandwiches, we need 4 pieces of bread. A 1 to 2 ratio again. So let's see, example number 2. How much water, or H2O, can be formed with 200 grams of oxygen gas? Coming back to our old equation, if you look at it, 2 moles of hydrogen gas plus 1 mole of oxygen gas produces 2 moles of H2O. We weren't given moles, so we have to change the amount of grams into moles first, then compare it with the moles of water. So, once again, we're going to use our T-chart here, and we're going to break it down into steps. So, I've got the 200 grams of oxygen in red, and as the first step says, find the molar masses of the given and the desired. Now, from the equation, you can see right here, the O2 is our given, right there, oxygen gas, right there. Right there, oxygen gas. Alright. And our desired is the moles of water. Right there, the desired. And if you notice, I've already laid out the molar masses of each compound. Oxygen gas weighs 32 grams per mole, and water weighs 18 grams per mole. So, we don't have 32 grams, we have 200 grams. That means we have more than 1 mole of oxygen. So, let's move on to the second step. Second step, divide the given by its molar mass. So 200 grams of O2, I'm going to place it in that box right there. And since we want to make sure we cancel units, I'm going to put grams of oxygen on the bottom corner, or at least to the diagonal of that. You can see that their units are the same. And on top, we have moles of oxygen, because every 1 mole of oxygen gas weighs 32 grams. Alright. Let's go on to the third step. I'm going to multiply or divide by the molar ratio between the 2 things that we had in question. In this case, it is, by our equation, 1 mole of oxygen for every 2 moles of H2O. Notice how that the mole of oxygen is on the bottom. That is because it is diagonal of what we want to get rid of. Alright. Fourth step, multiply by molar mass of the desired. The desired is H2O, and its molar mass is 18 grams per 1 mole. Notice how I have 1 mole of H2O on the bottom and 18 grams of H2O on top. Now, you notice all of these things will eventually cancel out if you multiply them all together. In some cases, divide. So let's see. How does this look on your calculator? This is example 3. Make sure you write that down. If I plug this into my calculator, it would be 200 divided by 32 because it's on the bottom, times 2 because it's on the top, and times 18 because it's on the top. From there, we get an answer of 225 grams of H2O. Notice how all my units at a diagonal have canceled, completely canceled. So that just leaves grams of H2O. I would surely, if under the right circumstances in lab, get 225 grams of H2O. You'll be doing this lab on Tuesday, and you will be collecting the results on Thursday during the short period. We will be using a different equation. We won't be making H2O. We'll be making actually salt, sodium chloride. Alright, tonight's death metal band reference is a goozy. It is Chimera.